Hello and welcome. This is still section 3 talking about quadratic functions, just part B. Our main goal today is to just solve a quadratic function. Again, from yesterday, a quadratic function is a type of polynomial with degree 2, which its highest exponent is 2. Again, just to highlight that, we have to have an x squared where a cannot be 0, but b or c could be 0. Again, we're talking about all real numbers here, so if we want to go back to the other day, we say a, b, and c, they are actually elements, all elements of the real numbers. So we're going to make sure those are a thing. Examples of what it looks like, well, we could have f of x is equal to, let's say, 3x squared minus 2x plus 7. We could also do like y is equal to just x squared minus 4. That works. We could do something like this. We could be like g of x is equal to just 2x squared and then plus 3x. Or we could just have like y equals x squared or something like that. Non-examples would be like, hey, we have y is equal to x to the third plus x minus 4. There is no x squared term. That is not okay. Or if we want like f of x is equal to just x plus 4. That is a linear term. So this is actually a cubic function to the third power, and this is a linear function just to the first power. So solving an equation. To solve an equation means to find all of the values of the variables that make the equation true. So what we usually do is we're going to set everything equal to 0. So if you have some sort of expression, let's say, and we're going to set that expression equal to 0, and then we're going to solve it. So set equal to 0 and solve, which means find the values that make it 0. So that would be what it means to solve. So just an example of a graph to see what it looks like solving wise. So if I have a quadratic equation like we've been talking about, we could have something like this. Our zeros are actually our x-intercepts or are our solutions. So we could call these, by the way, that's my x-axis. So we call these solutions. That is 1 and then 2 solutions for this quadratic equation, which again, this is an x-axis or x-intercept, sorry, we have x-intercepts here, or we call them zeros, or we can also call them roots, which is how we solve an equation as well. We'll talk more about that. There's also more ways you can look at this, because what if it actually looks something like this? Well, what if I have an equation that goes like this and just reaches down, and let's say it actually touches the axis, sorry, it wasn't close. It has only one solution here. So we would just have this as my single one solution. And I'm going to say it's a real solution. So let's just note that these are real solutions. And then we could have one last kind of looking thing. So let's just say we have an upside down one that never actually touches, never touches. I'm going to tell you that this one actually does touch. I just didn't get close enough. So let's say that really does touch that, only in one spot. This one would have 0, so 0 solutions. Again, we're going to just say, and we're talking about real solutions here. So let's go ahead and solve an equation that is already factored for us very, very nicely. So we have something times something is equal to 0. Now, this leads into the zero product property. The zero product property. And basically that states if we have a times b is equal to 0, then either a has to be 0 or we have to have b equals 0. There's only that thing. That's the only way this can happen, because it's like any times we multiply by 0, we get 0 as an answer. So like a times 0 is 0, or 0 times b, it also is 0. That is what we're going to be using. So we're just going to say, well, we have something times something. This is going to be my a, this will be my b. So if I think about it again, this will be like a, this will be like b, and we're going to set both of those equal to 0. So let's move this up a little bit. So let's just say that we have either 5 plus z is equal to 0, or we have this 4z plus 3 is equal to 0. And then we just solve each of those. So in this case, we just subtract the 5 to the right side, which I'm hoping you know how to do. So we get just z is equal to 5 here. Or, again, we get, in this case, we subtract 3 to both sides to get 4z is equal to, let's actually write this in blue, sorry. So we're going to have 4z is equal to negative 3 because we subtracted it. We divide by the 4 to get negative 3/4 for that z value. Now, what do I want to do here? Let's move that up a little bit, and we're going to write our answer as negative 3/4 and then comma 5. We have a solution set of those answers. We could write this in another way, in a set notation, but we're just going to leave it like that for now. So what we're going to do next is actually find the roots of a quadratic equation with a leading coefficient of 1, meaning there is a 1 in front of here. And if you didn't remember what a root is, that means your solutions. Solutions, we could also say the zeros. We could also say your x-intercepts. That's exactly what we did on the other page, where it crosses the x-axis. Roots are just another way to say one of those words. It's kind of like rooted. Where is it rooting or growing out of the x-axis? I think that's where it comes from. So again, we're going to look at this. There is a 1 in front of the u here, which I'm going to erase that because I don't like putting a 1 there just because it gets in the way. But if we have a equals 1, we could potentially factor this. Then we find the factors of c that potentially add to our b value. So this is, if this is factorable, we would have to do it this way, or can do it this way. So this one, by chance, is factorable. So in this case, we have equals to, let's just say not, well, we'll just say that this part is equal to, and we're going to have a bracket and a bracket. We're going to break it apart. And the only way to get u squared nicely is u times u. And then we're going to look at the factors of negative 28, which, if you think about it, let's go ahead and do that in red. So negative 28 is equal to, well, we could do negative 1 times 28. We could do 1 times negative 28. We can also do let's see, negative 2 times 14. We could also do positive 2 times negative 14. We could do negative 4 times 7, and then positive 4 times negative 7. Now, which ones of these? So I look at the factors of c. C is this. Which ones of these factors are going to add up to positive 3? Well, 7 and negative 4 add up to that. So we're going to put negative 4 and positive 7 here. And this is all still equal to 0 here. That is how I can factor it, which then we just say this is equal to 0, this is equal to 0, so u is equal to 4. 4 minus 4 is 0, and then negative 7 plus 7 is 0. So our answers would be this.